Okay, so async processing on server side. JAX has provide async processing on server side as well as a client side. Here we're going to mostly focus on server side. Yeah, actually 100% on server side in this presentation. Okay, so we're going to actually talk about technical background of server-side async operations, why that is in fact needed. And then we will talk about the concept of server-side push, or sometimes it's called the commit. Okay. Then we're going to see how server-side async could be implemented using JAX. And then we're going to actually play around with server-side async application. Is a chatting application. Okay. So async support on server side. Technical background. So the server side is very much concerned on scalability and performance, and factors that affect this server side scalability and performance includes thread resources. Thread is a very expensive resource on the server. So how efficiently these thread resources on the server is are being utilized affect the scalability. By the way, scalability means how many clients the server can support, and performance is how fast requests are handled. Okay? I mean, if you think about the emergence of this event-driven server-side programming model, such as Node.js, is because they tend to optimize the usage of thread, right? Like a Node.js is all event-driven, so in fact it has a single thread, and whenever there is an event, it will actually, delegate event handler. Okay, so that is a lot better way of handling. Event-driven model is a lot more efficient in terms of usage of threads. Okay, so that's a lot more scalable. Okay. And multi-core architecture of the platform should be leveraged. If you think about it, pretty much every single device these days, even your cell phones are multi-core. Some of them, I guess, and which means we need to actually process in parallel fashion. So each core should be able to actually handle some kind of process, and also functional programming is becoming popular to take advantage of this multi-core architecture. Okay, all right. So if you actually see web server scalability evolution, starting from HTTP 1.0 and HTTP 1.1, and then we're going to talk about the thread per connection and thread per request, and async servlet eventually. And these are all evolutions to make the server-side application to be performing faster and more scalable fashion. Okay, so let's talk about each of these in a bit more detail. HTTP 1.0 to HTTP 1.1 is a no-brainer. In the HTTP 1.0, every time you send a request, and it will create a brand new TCP connection, and that's obviously is not desirable. So in HTTP 1.1, a single TCP connection is going to be used for handling multiple HTTP request and response cycles, and that makes sense, right? And that's basically what the keep alive is all about. Okay, so persistent connections in HTTP 1.1 obviously reduce the communication lag perceptively, and also really because the client does not need to recreate TCP connection and destroy after each HTTP request and response cycle. Okay, so this is pretty much a no-brainer. Now, thread per connection, what is it? So it is used for enhancing scalability of web servers. So it is based on HTTP 1.1's persistent connections. Okay. Now in this model, each persistent HTTP connection between client and server is associated with a single thread on the server side. The server. So whenever there is a connection from the client, a thread is going to be assigned. And until that connection is closed, a thread is tied up with that particular client. Okay, so threads are allocated from server managed pool. Once a connection is closed, the dedicated thread is recycled into the pool and ready to serve other tasks. Now, the problem of this approach is that the scalability is still constrained because the X number of threads that you have on the server side can handle only X number of connections, meaning X number of clients. Okay, but if you think about it, for many websites, users request pages from the server, meaning users actually send the request sporadically. I mean, from computer standpoint, right? I mean, it sends a request and receive the response, and then maybe in a few seconds, it will send another one and things like that. Okay, so the connection threads at the server side are idle most of the time. Okay, and this is basically a waste of thread resource. Do you agree with that? So, a single HTTP connection is going to be tied up with a thread, and the thread is typically idle most of the time because a client and server communication is pretty much sporadic. It's not continuous. It's not using every single, I would say, nanosecond, right? Okay, so obviously this needs to be addressed in order to improve the usage of the thread on the server side. So that's the reason we now introduced a thread per request scheme. So thread per request is that it's based on, it's actually thanks to non-blocking I/O capability introduced in Java 4, JDK 4. Persistent HTTP connection doesn't require a thread to be consistently attached to it. Okay, so the threads on the server side will be allocated to connections only when requests are being processed. Okay, so the idle time between between two request and response cycle will be, during that time, the thread on the server will be allocated to the pool, and that thread could be actually be used by another client. Okay. So this model is called the thread per request because the thread is assigned only for handling that request. Okay, so this model called thread per request potentially allows the web servers to handle larger number of user connections with a fixed number of threads. So suppose you got 500 threads, you should be able to handle maybe 10,000 connections. Okay, so it will solve the scalability problem of thread per connection that we just talked about in previous case. So in thread per connection model, in previous model, if you have a 500 threads, then you should be able to, you can handle only 500 clients. But thread per request, you should be able to handle more than 500. It could be actually 10,000 connections and 10,000 clients. Okay, so that is obviously the more optimized usage of the thread resource. Okay, that makes sense? Okay, by the way, thread per request is being supported pretty much all web servers out there today. So there is nothing you have to do as a developer. Okay, so thread per request is what is being used by the servers. Okay. Now, if you think about the factors that further impact the scalability on the server side, one is AJAX. AJAX-enabled clients send more requests, a higher number of requests to the server than non-AJAX-enabled clients. Increasing the traffic between client and server caused a new scalability problem. So client will send more, higher number of requests to the server because it's doing AJAX. Okay. Now, the real problem is the second one. Thread, as part of the request processing, accessing slow responding resources. So you have received, suppose you are a server, you receive the request, right? And you're handling the request. And as part of the handling of the request, you have to actually access some slow responding resources, maybe the database or maybe remote web services, right? So during the time that this request is being handled, while it's actually waiting for slow responding resources such as a database and remote web services, this thread is actually again being wasted. Okay, so thread that handle this request could be waiting for a long time before response from those slow responding remote resources arrive. Okay, for example, database or remote web services. So we need to have a better solution than thread per the request model that we just saw. So what we want to do is we want to recycle the thread that are waiting for a response from remote resources by saving the request somewhere for later processing and release the thread. So as part of your request processing, as soon as you're actually sending a request to remote database or remote web services, we want to release a thread. And when the response comes back from the remote database or web services, then we want to assign another thread from a thread pool to handle that request and the response. And then you're going to create the HTTP response and send back to the client. Okay, so that is exactly, yeah, so this is basically that's exactly what async support in Servlet 3.0 is all about. Okay, so if you compare between the 2.5 and Servlet 3.0 model, on the left side, okay, so there is a client send the request, and this is your server application. And your server application is going to handle this one single HTTP request from the client, and it has to communicate with the remote resources. It could be database or it could be remote web services. Now it sends the request here, and it's waiting until the response comes back from that remote resource. So this duration, your thread is being wasted here. Same thing over here, right? So what we want to do is we want to release the thread during the duration that this guy is waiting for the response. So here it's going to send the request, right? And then the thread is going to be released. And here it's going to actually send the request over here. Again, thread is being released. Later on, when the response comes back from a remote web services or remote database, then we are going to assign a thread to handle that response. And then eventually it will actually use that thread to send back the HTTP response to the client. So we are actually leveraging the thread resources during this period. Does this make sense? Anybody had a question on this? Nobody? Okay. So yeah, this is basically showing why thread is in fact the precious resources, and it impacts the scalability and performance. So let's say we have a web application accessing remote web services with the following conditions. Maybe handling 1,000 requests per second. 50% of the requests call remote web services or remote database. And we have only 500 threads in container thread pool. So if remote web service is slow, it takes about a second to respond, then thread starvation will occur in 1 second. Okay, because 500 requests and 50% of the 1,000 requests will use all 500 threads. So until one of those threads are being released, there is no the resources to handle incoming subsequent request. Okay, so that is the reason async servlet or async REST addresses this problem. Basically providing this model in which when your request handling is actually sending a request to remote services, waiting for the response, we want to release the thread. Okay, all right. So why async servlets or async REST? Okay, so async servlet will reuse threads that handle requests that are waiting for responses, such as responses from remote web services, or waiting for resources. For example, getting a data from a relational database using JDBC connection, or waiting for some events like a chatting message. Okay. So in a chatting application, so I'm going to talk about that aspect in the following slide. Okay, so I gave you a background information in terms of why async servlet architecture is in fact introduced in Java. So Java was in fact behind the curve and behind the other this event-driven model such as the Node.js, right? Node.js is completely this event-driven. And the Java was not, and Java now introduced the this async servlet for web application, and also in Java community they are actually introducing reactive Java, which is basically reactive programming model that is being adopted again to provide the higher performance and higher scalability. Okay. Moving forward, quick tutorial on server-side push. So anybody has heard of server-side push or Comet or Ajax push or reverse Ajax? Anybody has heard those terms? Yeah, this is pretty Yeah, I'm sure you did. Okay. So let me actually explain what the server-side push is all about. Okay, the first generation AJAX is not asynchronous enough. It handles the client-to-server asynchronicity. So it handles single-user client-server asynchronicity only, but does not handle server-to-client asynchronicity. In other words, the server cannot send data to the client whenever it wants to. Okay. So that is a first generation AJAX, which handles only one side, one direction asynchronicity, meaning from the client to the server, but it does not handle server to client asynchronicity, meaning basically whenever there is interesting event on the server side, we want to propagate that interesting event information to all clients. Okay. So full asynchronicity includes updates pushed from the server to the client, meaning server to client at any time. Okay, so server-driven page update at the client. So basically allows multiple users to communicate and collaborate within the web application. So examples include the chatting application, auction application, online gaming application, and things like that. So what that means is that instead of actually clients polling the server, we want the server, whenever there is interesting event such as newly arrived chatting message, that server should be able to send the data to all clients. So that model is called Comet server-side push and AJAX push and reverse AJAX. So these are possible example applications with the server-side push, like a chatting. So instead of actually each user polling the server to see whether there is a new message or not, what we want to do is that whenever there is a new message comes in to the server should be able to propagate that message to all clients. Whether the number of clients are 10,000 or a million, you should be able to actually, propagate that message to all chatters involved. And auctions, so I'm sure many of you are participating. Many of you have actually used eBay, right? Long time ago, I don't use eBay that much anymore. Every time you actually make a bid, you have to actually kind of poll to see whether other people have outbid you, right? You just kind of click the link. Basically, that's polling. Instead, what you want to do is that if there is actually another bid by another user, you want to get the notification. So if 10,000 people are actually bidding on a particular item, whenever there is a new bid, you want to actually get the notification. Distance learning is another example. Basically, whenever online instructor is changing the slide, or whenever there is a question posted by the attendee, we should be able to get that information to be propagated to all participants right away. Online gaming as well. Every time there is actually interesting move by online game player number one, that should be propagated to all participants, right? So there are many applications that could actually take advantage of the server-side push. So the Comet or reverse AJAX or AJAX push is basically responsive, low latency interaction for the web. So it's a programming technique that enables web servers to send data to the client without having any need for the client to request for it. Meaning, instead of actually client polling the server should be able to send data to all clients right away. Okay, so it enables the creation of highly responsive and event-driven web applications. So it let the clients to be up to date with data arriving or changing on the server without polling. Okay, so obviously advantages include low latency, not dependent on polling frequency, and server and network do not have to deal with frequent polling requests to check for updates. Okay. So the way they do is basically, I'm going to actually show you how they have done this before HTML5. Okay, so obviously AJAX, the Comet or reverse AJAX, and as you're going to see in the following slide, is actually using some kind of kludge scheme to make that happen. So HTML5 actually introduced native support for doing these things using what is called the WebSockets, and that is also what is called the server-side events. Okay, but that's HTML5, and we are assuming we are still using HTML4. Okay, yeah, so this is actually this is polling and this is AJAX push. So when you're actually using AJAX push, we have a long poll scheme and streaming scheme. So this is the polling case. The client has to send the request to the server, and the server says, I got nothing to show you, nothing to send to you. And when there is an interesting event happens, and then it's going to wait. Client has to wait until this much time. It's going to send another polling request, and then response is sent back. Okay. Now in reverse AJAX or AJAX push, basically the way they support this scheme is it sends HTTP request, and on the server, instead of actually sending back the response, it will wait until there is an interesting event. So if there is an interesting event, and then it will send back the response. And the client will send another request, and until there is another interesting event, the server does not send back the response. So this is called the long pole because as far as the client's concerned, this is the server is pretty slow server, right? Another scheme of AJAX push is using streaming. So here you send the request, and then whenever there is an interesting event, it will send the response. The problem of this approach is that you have to change the client-side code. This one, you don't have to change the client at all. So the long pole is actually a more popular scheme for handling server-side push. Okay, so this is basically what I just talked about in the previous slide. Okay, all right, so the server-side asynchronous processing using JAX RS. Okay, yeah. So before we move on, any questions? Question from Jonathan: does this include WebSockets? I'm not sure I understand your question. When you're saying this, what do you mean by that? Are you saying that whether the async processing in JAX RS is actually built on the top of WebSockets? The answer is no. So that was in earlier slide. So you are saying, yeah, this one. Yeah. So this is HTML5. We're not assuming we are using HTML5 at this point. Okay. Okay. Good. Yeah. Moving forward. Okay. So how we are going to support this asynchronous processing on the server side. Okay. So as I said, JAX RS provide async processing on the server side and client side, and again we are just dealing with a server side only. Okay. So server side async processing allows higher scalability through the efficient usage of processing thread. So whenever there is actually a need to wait for some responses from remote resources, you are going to actually release the resource. The thread, and so you are going to actually use the thread resources more efficiently. A thread that is processing a request should avoid blocking while waiting for external tasks to complete. For example, waiting for remote responses from remote database or remote web services and things like that, so that other requests arriving at the server during that period of time can be attended, similar to async processing support in Servlet 3. Okay, so basically, the same async processing support in Servlet 3.0 can be actually used for RESTful operations as well. So accessing remote RESTful service resources from Twitter or Facebook, for example, can now occur without blocking other clients while requests being serviced. Okay, so talking to Twitter or Facebook or remote databases or remote web services, these are all examples of the thread being blocked. And those blocked threads could be actually reused if you are taking advantage of async processing. Okay, all right, good. Let's see. So here, so this is how you're gonna actually build your server-side application using async. Okay, so I have async resource, and it's going to it has the path of simple async here. Okay, now your method that handles this get request, you're going to actually make this code to be functioning as async by using suspended annotation. Okay, so you're using suspended annotation, and then what you're actually getting is the async response object. This async response object is basically capturing the request and response object. Okay, so typically what you are going to do is you are going to queue this async response object somewhere so that another thread can handle it. In this example, as a way of very simple demonstration of simplest possible way, we are creating our own thread, okay, and trying to handle it. So here we are creating a new thread, and we created a new thread with a runnable type, and then basically we are going to perform very expensive operation. Maybe it's calling a remote database or remote web services or Twitter or Facebook or something like that. And once that is done, then we are going to actually get the async response object, and then we call resume with this result. Okay, so the the idea is that the async get method will be returning to the system right away, which means the thread that started this async get method is gonna be returned right away. And in the meantime, another thread will be actually taking this async response object and will actually perform very expensive operation. And because async response contains request and response object, it will use the response object, the HTTP response object captured in async response, and it will actually return to the client. Okay. Yeah, so again, in the chatting application, you are going to see this async response object will be in the blocking queue. Okay, in this case, we just want to demonstrate the simplest possible programming model. Okay, all right, moving forward. So this, you can also actually have a timeout. So basically, if you want to, you don't want to actually wait like indefinitely, right? So you want to wait maybe the 200 milliseconds before you are sending back the some kind of response, okay, to the client. Okay, so this is for setting the timeout. So once you got the async response object, you're going to call set timeout handler, and this is a timeout handler. Okay, when timeout occurred, we are going to just so basically when timeout occur, we are going to actually resume, and here we are actually setting the response status with service not available, and then we are going to actually the entity, meaning HTTP response, is going to be operation timeout, and that's what gets returned to the client. Okay, all right, and in this case timeout is set with the 2 millisecond. Okay, so we're going to actually play around with this in our hands-on lab. Okay, so we're going to do exercise 1 and 2 of simple async processing. So let's import the project, existing Maven project, and labs async. Oh, I already imported it. Okay. So let's see. Yeah, okay, here. Yeah, I'm gonna just close this project. Okay, so let me let's actually see the lab documentation. So async. Okay, so the first exercise, we are gonna do async processing without the timeout, and second one is with the timeout handler. So we are going to run the async simple server web application. So we are, this is a client code. You can actually click this guy, and then we are gonna actually receive information after a few seconds. Okay, maybe 3 seconds, and we can certainly actually use the call command as well. Okay, if you take a look at the code, yeah, this is exactly the same code that we have seen in the slide. So basically, this async get will actually receive this async response object. Okay, and basically we are just starting our own kind of background thread to handle it. So we are actually performing this very expensive operation for performing this creating a math square root, and once that is done, we are just returning with the resume of async response. Okay, let's see. So for your own exercise, you're gonna actually convert create order. Create order. Typically, it will involve it will involve talking to relational database, right? So that certainly will have a very expensive operation. So this could be in fact the good code to make it as an async code. Okay, so basically I'm actually asking you to convert this code to be functioning as the async the code. Okay. All right, so let's actually run this guy. So that is the simple async server. Oh, okay. Oh, I didn't stop the previous application. Okay, so let's just start it again. Okay, so it's up and running. I'm going to use the call command. So here you can see there is a delay, right? There is a delay that this response is being returned. Okay. Oops. Right now it's kind of fast. You can certainly actually increase the number of square root computation higher, and there will be some delay. Okay. Yeah. So delay is actually from this guy. Okay. The next one is we are going to introduce the timeout. Okay, so we don't want to wait forever. So in this case, we are basically setting a timeout. Okay, so the timeout we want to wait is just 2 milliseconds. Okay, because we want to actually enforce the timeout. So if computation of this is taking more than 2 milliseconds, then we should actually have a timeout. Okay, so we should actually receive the timeout message. Okay, so you should actually receive the operation timed out message that is coming from this guy. All right, so let's run that application. Okay, so yeah, let's stop that guy and simple server with a timeout Java application. Okay, so now we're gonna actually run the so we have this timeout things. So we are going to what is the URL? Well, I'm gonna just run from the browser. Okay, so this is the if I click this guy, we are this message generated from async processing thread. Oh, why timeout is not actually okay? So we maybe not enough have so we want to actually change the timeout. Okay, period to 2 milliseconds rather than 2000. I think right now it's actually 2000. So in this code. Yeah, so this is 2000 milliseconds. So we're gonna just change it to 2. Okay, and let's restart the application. So we're actually forcing kind of timeout. Okay. Okay, so it's restarted. So now let's. I'm going to run the application again. This time you should have timeout timeout. Huh? Why it's not actually? It should timeout. Oh, it still doesn't work. Why is that? So let me just make sure that I am in fact running the correct application. This is timeout. We have a timeout. We changed the timeout here. Okay, so let me stop this guy and run as Java application. Okay. Now the call command should actually still work the same. Yeah, okay, so the call command actually operation timeout. Okay, so that worked okay. So let's actually try to use the browser. And browser should actually work the same. Okay, so let's okay, so it worked as well. So maybe I was not running the correct application. Okay, so that is exercise 2. Basically, you are playing around with the timeout. Okay, for your own exercise, add timeout handler code to the create order of the previous exercise. So I'm going to give you guys about the 13 minutes to do exercise 1 and 2. Okay. So one of the sample application that could take advantage of the server-side push application using async servlet on the side on the server, or actually in this case async REST is the chatting application. So that's what we are going to actually try. So what we are going to try is that we are going to actually run the chat serve application. This is the chat serve application that take advantage of async REST request handling. And then we're going to have a 2 clients application. And basically, the serve application, whenever there is a message being posted, you should actually disseminate or distribute that message to all clients connected. It could be thousands of clients that are connected to this chat server. So as soon as one chatter posted a message, that message should be distributed to all clients. So that's the idea. So let's run this guy. So we are going to stop the server. So you can see we have an async chat server and we have async client 1 and 2. So let's actually run this serve application, run Java application, and here. Okay, so now the serve application is up and running. Now we're going to run the client 1. So run as Java application and chat client. Okay, so okay, so basically, I can actually post a message, hello JPassion.com. Okay, so the client 1 is actually using Sang as the username, and then I have a client 2. I'm going to actually run the client 2, Java application. So here, life is good. Okay, so the client 2 is John. So now you can see, as soon as client 2 joined and posting the message, the message should be able to be propagated to all clients. So if I take a look at the client 1, you can see John's message has been posted to Sang. So here, as a Sang, I'm going to actually say code with passion. And that message should be viewable in the John. So John, seeing the message from Sang. So idea is that every time a message is posted by client, the chatter client, the server will disseminate that message to all clients. So again, it doesn't matter. We have an example where we have only 2 clients, but it could be thousands of clients or even millions of clients that should receive this message instantaneously. Okay, so that is the idea. So let's actually study the server-side code. Okay, so here. I'm gonna just use this guy. So this is the chat resource and chat. Okay, So we have a linked list map, and this is the message that we are going to use. This is the link hash map we are just kind of maintaining in the form of string and messages. Okay, so we have listeners. This is the linked list async response. This represents all suspended responses. Each of these responses represent a chatter waiting for the new message. Okay, so linked list of async response, and each of these represent new chatter. Okay, and then so whenever there is a post message, we are going to actually see we are basically going through these listeners, and then we are sending the message to each client. So this listeners is representing the all suspended responses, which means that each of these listeners represent a chatter. Okay, so basically we are just sending that message to all clients. Okay, that is basically the idea here. Okay. So here, let's see, synchronize new message. Yeah, so basically we get the message object, and we get the message ID. We are setting the message property with the text, and we are checking whether it is a first message or a last message, and then we are actually putting that message into messages. If you see here, message is the linked hash map. Okay, so that is a message that has been queued. Okay, and then we are just sending the message to all listeners, meaning all chatters. Okay, and the idea in this case is, if you take a look at the resource, basically what we have is what is actually I'm looking for suspended. Where is the suspended? Oh, here we go. Okay, yeah. So suspended. So here, when we actually have a get, it's going to receive the request suspended, and we create a message. And let's see. Oh, so the idea is that we are basically adding that async object into the queue. Okay, yeah. So queue, yeah, basically, yeah. So we are just adding a brand new the chatter to the listeners object. Right. So this is actually starting point of the chatter to be included in the queue of the listeners. And this is the sender, this message. Okay, so the key point is this guy. The receive is the method that is invoked first, so that the chatter, the async response, will be actually queued up into the listeners. And let's actually see the client code. Okay, so client code, the first thing it does is the client does have, so this is an example where client is actually doing its own async operation. We haven't really talked about the client side async, but even client actually perform the async operation. So JAX side support the client and server side async. Okay, so here what we want to see is client. So we got the client object, we got the target object, and then we actually creating a request object, and we want to actually make it as a async, and then we are going to call get, so basically this get message is going to call this guy receive. So that's the first thing it does. Okay, And then whenever you type a message, so then we have a while loop here. So while loop, is basically receiving a data, then it's going to call post. So whenever user types, so this is actually being called first. So user will actually, be included. So if it will be included in the queue. And then whenever user types something, which is basically this while loop, user is going to actually type something, and that will be sent to the server as a post request. And that is this post request handling here, this guy. Okay, yeah, so as long as you understand this code, how it works, I mean, that should be good enough. Okay, I just want to actually show you a real life sample applications that take advantage of this async REST support, async REST, the processing on the server side. Okay, all right, so I'm going to